Solving a formula for a specific variable. This is actually a really important skill, um, especially, I mean, like a lot of our stuff is computer driven now, and if you're ever going to use spreadsheets or anything like that, you have to be able to solve for a specific variable within an equation, or if you're going to write software, you're going to have to be able to solve for a specific variable to use that equation in the software. So let's say we wanted to solve this equation. This is we've all seen this one, distance equals rate times time. And say we wanted to solve for rate. So typically what happens is you're given a problem, and maybe it says like the distance is equal to 10 miles and the time it took was 2 hours. How fast were you going? And so what you would do is you'd plug in your values, 10 equals r times 2, and then you'd solve for r. You divide by 2, and you get r is equal to 5 miles per hour. Almost forgot my units there. So that's a perfectly fine way of doing it. It's just that it works for one situation when d is 10 and t is 2. So what you want to do in this case, what we're trying to find out is what's the relationship between r and d and t. So we'll do the exact same thing we did up here, right here, except that we're not going to plug in any numbers for these variables. So to get r by itself, I would undo what's happening to it. It's being multiplied by t, so I'll divide everything by t. And now I have d over t, that's not a t, d over t is equal to r. And that is d equals, or distance equals rate times time, solved for r. So we can use this to our advantage when maybe we have to do solve a whole bunch of equations. So instead of plugging in our values like the 10 and the 2 and solving each time, you could solve it once like this, and then just plug in your d and your t over here, and you just do 10 divided by 2. Or if, let's say, d is 50, you plug in 50, and then t is 20, you plug in 20, so you have d over 20. So it's just you solve it once, and then you can plug in your values over and over again. Let's look at a few more examples. One more thing before I move on, I almost forgot. So we call these like this, where there's just a whole bunch of letters in here, a whole bunch of variables. We call them literal equations. Literal. A definition of that would be related to or being comprised of letters. And sometimes even variables are referred to as literals. So really just, like in this case, we're solving literal equations for other variables. It's kind of like just saying, like, taking an equation with lots of letters and solving for one letter in particular, or taking an equation with a bunch of variables and solving for one specific variable. That's it. So we're working with literal equations here, is what we call when they have a whole bunch of variables like this. So here's an equation that we're all familiar with, and maybe the directions are solve for, let's solve for h. Okay, so we have to try to undo everything that's happening to h and isolate it on one side. So I'm going to start by multiplying both sides by 2. So I'll multiply this by 2 and multiply this by 2. And so this will become 2a equals, and of course this equation is a equals 1/2 base times height, so, or b times h, which is the area of a triangle, or the equation that we use to calculate the area of a triangle. So we're going to solve for the height. So now I just have this, 2a equals bh, because when I multiply both sides by 2, obviously this becomes 2a, And then this 2 is going to cancel with that 2. And because there is no distributive property here, because there's no addition or subtraction, this is all just multiplication, then I'm just left with b times h. So my next step is to get that b away from the h, so I'll divide both sides by b. And now we get 2a over b is equal to h. And so now we have just rearranged this original equation where it was solved for the area, and now we know what h is for the when you have a triangle and you want to know its relationship between the area of that triangle and its base. Okay, so we've successfully solved for the height of a triangle given the area and the base. This is another one you've probably seen in science. This is the relationship between the Celsius, the temperature in Celsius, and the temperature in Fahrenheit. So if we want, this one tells us, well, here Celsius is when you know the temperature in Fahrenheit, this is this expression over here represents the temperature in Celsius. So let's rearrange this so that we can find out, if we know the temperature in Celsius, what is the temperature in Fahrenheit. So let's start to kind of undo and chip away at this so that we can get F all by itself. And so I'm going to just start by, let's do what we did the last lesson, and I'm going to clear my fraction. So I'm going to just multiply everything by 9. So now I have 9c equals 5, and this is going to look strange, but I don't actually have to distribute the 9 into here and here, because I'm just multiplying it by everything here, and this is going to be, this 5/9 is multiplying into this, so this 9 will cancel with that one, and then we're just left with this. So now we'll distribute this 5 into here and here. So now I've eliminated my fractions. I've got 9c equals, and then I'll have 5f minus, and then 160. So 5 times 32 would be 5 times 30, which is 150, plus 5 times 2, which is 10, so that should be 160. And now all we have to do is solve for f. So add 160 to both sides. So I've got 9c plus 160 equals 5f. Divide everything by 5. Divide all this by 5. So now we've got 9/5 times c plus, and then 160 divided by 5 is 32. And that will give us f. So we can rearrange this so that f is first. So f equals 9/5 times c plus 32. And this is how you calculate the degrees Fahrenheit if you're given the degrees Celsius. So this equation should also look familiar to you. This is just the equation of a line. I have my y values, this is our slope, x is the x values, and then b is the y value of our y-intercept. So this is we commonly call this the slope-intercept form for a line or linear equation. So what if we wanted to know, well, what's the relationship of slope to the rest of this stuff? And so what we can do is just solve for m. And so we'll do that by starting off, we'll just subtract b from both sides. So now I have y minus b. Can't combine those because they're not like terms, so we just leave it. So I have y minus b equals x. And then I'm just going to divide both sides by x. Now I have m equals y minus b over x. So if you ever want to know the slope of a line, and you know a point on the line and also the y value of the y-intercept, you could just plug it into this right here, and it would give you your slope. So I'm going to rewrite that. So we've got m equals y minus b over x. And that is the slope-intercept equation solved for the slope. So this is going to be a problem that's very similar to one that you're going to have on your practice set. Here's the equation that we're given. This is the equation that we use to calculate the area of a triangle. So the area is equal to 1/2 the base times the height. And then this says solve for b when a is equal to 126 and h is equal to 18. Okay, so that's kind of similar to what we've been doing. And then after that it says also part B is to solve it in general. And that's just like solve it like a literal equation. So we'll just solve for b, but leave all a and h in there as a and h. So we have two separate problems. So we have a is equal to the area is equal to 1/2 base times the height, and we'll plug in our values. So 126 equals 1/2 times the base, and then the height is 18. Okay, so this is going to be 126, and the 1/2 times 18, so that's just going to be 126 equals 9b, so I'll divide both sides by 9, and 126 divided by 9 is 14. So b is equal to 14 in this case. So that's part A. Part B is to solve it in general for b. So area equals 1/2 base times the height. So I'm going to multiply everything by 2 to clear my fraction. So now I have 2a on the left, and then we'll have just bh on the right. So to get b by itself, I would divide by h, divide this by h. So b is equal to 2a over h. And I can rearrange that so it looks like this. B is equal to 2a over h. So there's our literal equation solved for b. And this, you can leave it like that, and then this one is down here. I don't think that that it asks you to plug in, but if you wanted to, you could take this and now just plug it in for a and h, and then solve, and you would evaluate this, and you would get what hopefully b would be the same as 14. Okay. Alrighty, that should do it.